Welcome to the lecture series on object-oriented analysis and design. In the last lecture, we have simply discussed the fact that there are no industry-wide accepted definitions of the terms requirement, analysis or design. Right in the title of this series, we have analysis and design. There is no reason to think that this is exactly analysis, this is exactly design, this is exactly requirement. One of the reasons why we keep saying that our success rate in software engineering has been very modest at 36% is because of the fact that we entertain a huge instability in requirements. In other words, 70% of the requirements are volatile, and we are blessed if 30% are nicely defined. So, what we have done therefore is that the nature of the field is like that, and definitions of these terms are often the subject of almost religious debates. We have been fighting, we have been taking stances almost to a point where we do not have any return. So, what we have learnt first is separation of concerns. Whose concern is what is a simple question that we asked. So, we said that for the present, if we had perfect implementation technology, a computer with infinite speed, unlimited memory, transparent interface, no failures and no cost, which of the requirements would still need to be stated? So, what we said was, let us first bucket the things. Certain things, many things in the beginning are technology, because people want to find out what is it that this technology can do for them, not what is the problem they are having. We have to get them started in a manner where they talk about their problem, not try to find out what is this technology that is going to do them with or help them do. These are two different matters. So, the people who are the customers, who are your stakeholders, who are willing to pay for this software, they need to be nicely positioned in a manner where they talk about the problem. They talk about what is the problem for which they are in search of a technical solution or a solution. A part of it may be technology, entirely may be technology. At the time when they were talking about the problem, we do not want to talk technology, because it may be there, may not be there, it may happen 10 years later, it may happen 20 years later. So, what we have been thus doing is, first things first, technical concerns can come later. So, when we are really talking about requirements, let us talk about the problem, the context, the domain. Those are the dominant ideas that should come. Technology will come a little later. Every requirement that is still necessary in spite of perfect technology is an essential requirement. Well, it is a very crude and a very simple way of telling that we do not analyze more and more of technology. What we are talking about as analysis and design is more aligned to the essential requirements which we have found, which are not talking technology. It is not the task of a software engineer to illuminate people on object oriented technologies. It is not the task of the people who are developing to talk about how this technology is comparable to other technologies. It is a problem, it is a solution. Once we remove the technologies, bring them back a little later. However, most of the times we forget, and eventually what happens is, most of the monies will be spent on solving the problem, because that is where the customer understands where to spend. Technology is not something that the customer really understands straight away. So, he does not know why he should spend so much time on so much money on mouse. Let us say, what is the need for that when the keyboard is here? You have to explain. So, these are certain concerns which we will talk about later, but most of the time the money bag will tell how much technology can be used. We have a budgeting provision, we have a way of estimation. In all these cases, the functionality reigns supreme, and we cannot do away with the top down analysis, because right at the beginning we need to give the estimate. It is not that we finish the job and send the bill saying that this is how it is. So, this is how we have been talking about. We are completely different from what the healthcare professionals do. They heal and then send the bill later, but then we have to first tell the estimate and then get an approval and then go ahead with the work. We are completely different. Every requirement that is still necessary in spite of perfect technology is an essential requirement. So, what is this analysis talking about? It is talking about the essential requirement. So, what happens here is that it is true that all these things are requirements in terms of speed, cost, capacity, mean time between failure, MTBFs, reliability statistics, requirements about IO mechanisms, requirements about computer languages, but most of the matters related to technology except the very last one, saying that requirements about archiving are primarily dealt with in the design bucket. Now, what is happening is we need traceability, two-way traceability of requirements. So, we need to keep track of it. People are not so clear minded. In this meeting we said this is the most important requirement, next meeting they will it is not such an important requirement. So, requirements, requirement documentation, requirements traceability, all these things are necessary, and then we started having a nice archiving mechanism which tells. So, for example, these days it is very commonplace to have shared collaborative platforms which track about each of my contribution which is connected to the collaborative platform. I can get my post, I can get my audio clipping, I can get many things. Well, we can simply tell that all these things put together are a way of looking at the requirements in a manner where the analysis and design will always be well guided. It is not that the customers are misleading or the customers are not clear in about what their priorities are, business policies are, but then the way in which they discover the problem themselves makes them talk like that. So, repeated meetings, repeated exercises, we have thus been giving the cake to the requirements phase, and we know that that is such a most challenging phase because 70% of the requirements change. So, when we talk about design, we are using technology to tell people that we have to freeze certain things now, otherwise there is no end to it. The technology available right now is like this, the money bag we have is this, therefore, we freeze this technology and this is how it dictates terms. Technology is seldom neutral, one technology kills another technology is a myth. We have to weigh the various options, weigh various technology options and tell that amidst the current context and amidst the way in which we are doing, these are the technology options and we have to freeze. So, at a point when we were thinking of going online, which online environment? So, gradually the idea of Zoom caught on and people started telling that Zoom is the nice online platform, whether we like it or not, we are living with that. WebEx is there. People have been talking about WebEx, but the most dominant, there are so many online tools, most dominant happen to be Zoom, WebEx, to some extent Microsoft Teams, but otherwise it is like that. Requirements about the customer's business policy, business process go into the essential bucket. There have been other event managing software we have been talking about, at least 5 I have been using in the last 4 or 5 months, but the most dominant are this. Each one has its pluses, each one has its minuses, but then for the kind of an exercise that we are doing, it is not such a hair splitting debate that is necessary on these technologies. We want a facility where up to let us say a dozen speakers have a way of appearing on the screen and speaking. We can have about 200 to 300 people logging in, a chat facility, a documentation of the chat facility, and that is just about it, an audio video connection. So, for the bare minimal kind of a thing where we want to get on with these online technologies, it is not really a hair splitting debate. So, what we said was, as many things walk into the design bucket, please do not worry about it, we are not likely to spend so much time on choosing the technology. It becomes more or less apparent because of the constraints, because of the financial constraints, because of so many other timing, financial, so many constraints, it becomes very apparent. So, where is our maximum time going in analysis and design? The requirements, and we strongly think that object oriented is giving us a great edge on understanding how to do the analysis in a manner where we do not have to wait for the full analysis to be completed. As the analysis progress, as we are able to recognize, identify the object, which is the essence of this of the last lecture, as we are able to identify and model the object, we can get started. Let the analysis be completed, we will put them together, we will put the components together and say that yes, we have done the job. Applying the principles of coupling and cohesion at the highest level of software architecture, more robust, less fragile systems enable separate evolution of the business policy, business process and the implementation technology. So, I begin with architecture first, because that is where we have been telling that it is easier to link up the top phases of requirements, specification, high level design, detailed design. They are all nicely visible, they reflect well in the software architecture. If the separation between business policy, business process is carried through the architecture and into the code, the highest level of software architecture will appear as follows. This is how it is. The essential core becomes very obvious, and that is where the architecture is necessary, implementing this portion of the essential core that is automated. This is the essence of the exercise. Good object oriented analysis and design not only takes you to the architecture, the topmost level, but also sees you through until the retirement, deployment, implementation, everything goes on well. So, we found that for the set of applications where object oriented analysis and design is a correct technology choice, it does well, it builds well, it keeps all the users involved, but then it is paying only at a grade of complexity, nothing less than 50,000 lines of code, not for simple toy programs, but something like a lakh of lines of code now. Unless you have an application that is demanding a lakh of lines of code, object oriented analysis is not likely to have a good considerable return on investment. However, what we have been talking about is the fact that yes, we are building, things have changed, the software industry has gone through its ups and downs, and what we have been talking about are now the dominant ideas are agile processes, not such a huge long drawn project, but we are talking more about products and we are talking about mix and match. Please see what is available. So, the bottom up idea is now catching up much faster. You have a problem, see what is available, see what is that set of components that you can put together and you see a solution, reasonably good solution, maybe not an exact tailor made solution. So, once again we start talking about the advantages of tailor making a solution and what is ready made, you just put them together and get on with the job. So, we have been seeing so many things. Some years back we were talking about robotics competitions. It is so nice that the school children will run around, scout for the components, they have an idea, they can put them together and make a robo happen. It is so nice. It is so nice to talk to them. They may not understand what is going on inside the component. The skill level necessary is also coming down because they have an idea. The students from the schools, they have an idea, they have a teacher, they have a principal, the idea is there, but then they do not have to go through a full robotics course, they need not get a PhD in understanding what is the electronics that is going on. They are quickly looking at the component. It is fascinating to talk to them. How did you find out there is this component? I have seen it somewhere, I have seen it in a movie that something was happening, I tried to explain how that thing happens, and the shop person told this is what you should do to try it out. So, we have tried certain ideas like that, and E-Yantra was a government of India initiative. They were sending a base on which you can do so many things. These are all ideas that are built around those simple starts of games and puzzles like Meccano, the mechanical engineering of the Lego toys. You can build things together. Essentially, the object oriented paradigm has created the fact that first look for things what is existing. So, it is not entirely build from the scratch, build some, buy some. You have to use certain things that are existing. So, today the software industry has turned around and it is now talking about small pieces, agile processes. There are so many things that are existing, see how they fit together. It may not be a tailor made solution, but then it is worth it because it is quite fast. Now, the concern in software is that we cannot simply allow that to happen without any cross check. Say for example, for this well defined set of input data, this is a well defined set of output data. If you get more than that, it does not mean it is a bonus or a discount. You cannot talk about anything like that. So, it should be that exacting. For a given well defined set of input data, it should be the well defined set of output data. Now, in many of our ways of working in the context, it is not so readily obvious that we can achieve this. So, therefore, we still need all these exercises of architecture, all these exercises of analysis and design to make sure that the well defined input data will be transformed into the well defined output data. If it is doing something more or less, we will have to tailor the exercise. If you are okay with this bottom up, in the sense that we will have the existing components knit together to show us a quick solution, to show us 30% of the solution, then we are up and running. We can invest further. We have, it is more than a prototype, it is not a prototype, but then it is showing some functionality happening with the existing components. It can happen, provided you are doing in application areas which are very steady, and that is what we used a term called reusability. That is a term called reuse. You have built certain things, you reuse them. It can happen in accounts. We have seen some good accounting packages. Tally was doing very well. It was a popular account package. I do remember that during my work with the Directorate of School Education, they were in Tamil Nadu, they were talking about introducing Tally as an accountability package, and now what has happened very soon after that, it was realized that we do not need the entire Tally package, we need only some modules out of it. So, that also happened. The object oriented people started telling that we will give you only half a dozen functional modules, which when put together will give you an idea about what is this accounts package all about, what it will do. So, however, what we need to understand is that technology choices are elsewhere. That is not an essential requirement. What is the goal? I want to do this. This is my problem. I want to solve the problem. That is how it is. So, what we need to understand is that between this point, this bucket, addressing this bucket and this bucket, what happens is clearly your problem specification. It is independent of technology, it is independent of any domain that is specific, independent of any stakeholder. So, the ideal abstraction is what we try to do. In object oriented, we end up with a good model of the business policy or the business process. That is the essence of this exercise in object identification and modeling. In the very beginning, I have taken recourse to using some C++ code segments to illustrate that whatever we have been talking will eventually become a technology dependent model of the solution which we are talking about. So, you have to choose a language for programming, some technology decisions will be enforced. They become very apparent very quickly, whether you are doing it in Java, whether you are doing it in C++. So, what we have promised is in the OOAD with the case tool supporting the unified modeling language, you can come up to it in as much time as you can take. Once you have reached this phase, once the design is over, you have to simply choose a language, click a button, everything will happen. The machine architecture is also built in, everything comes very early. So, the focus will shift very correctly to what is the problem we are solving. We cannot completely ignore the problem because we are coming out of the context, coming out of the domain. We quickly lose focus. In the earlier methods, we were losing focus on this. Very quickly we talk about technology, very quickly we talk about what is available. In other words, in the limited time that we have to develop our requirements, gather or elicit or engineer our requirements, we spend more time on making the customers talk about what is it that your technology can do. First you explain, then I will see what is that I can fit with my problem. Well, there are so many things, as I said, serious fights have broken. We required third party arbitration, mediation, because they think that they are absorbing their entire business logic or business dynamic, business intelligence, and then going away doing nothing. So many things are there. Businesses are businesses. We should not really do anything untoward on the matters related to the ethics and the way the business dynamics are controlled. There is a monopoly and trade restricted practices. So that is how it is. So restricted trade practices is there. So what we need to understand is that the essence of object oriented analysis is to somehow finish most of it here at that abstract level. Once we finish this much portion, we will simply run it out as technology idea, frozen decisions. It has to simply go ahead. We get plenty of time to focus on the problem and the solution. The idea is simple, but then it is lot more easier said than done. We need to focus more on essential requirements. Again, after all this, we still have the same problem. Even 70% of this would want to change dynamics. How does object oriented help us cope? All this exercise up front in the domain of object oriented analysis and design. So that is what we are doing now in this topic called knowing object oriented, which is moving out now. What we are planning to do is to understand the abstract ideas which can be couched in some language. Simply because I have used C++, it does not mean that C++ is the only object oriented language that can solve the problems. It is not at all like that. I found, as I was going through the syllabus books for MSc in computer science, I found that most of them study C++. Object oriented analysis and design forms a part of the curriculum there. Just looked at some courses here nearby, and we found that I found that C++ is taught in many MSc computer science courses. So the code segment looks like that. So now the real challenge is that how do all these ideas that are being that I have been talking about in object oriented analysis and design simply give us a confidence that if it is couched in a language supporting this many features, we can solve the problem. That is the way we should talk. Any language that supports these features should be good enough. So what is this knowing object oriented? Essentially, what is the idea? As I have been talking about, we need to have this paradigm to focus on improving the people productivity. People should not be bogged down to the technology. People should be concentrating on the problems, solving the problem. So that is where the keynote is, problem solving. After the problem is adequately solved in the manner which I have been discussing, it should have an ease of expression, should be easy to express. What are those ideas which, when implemented in a chosen language, gives us an assurance that yes, it is a working solution without learning too much about that language. Ease of debugging, ease of verification and validation, prevention of errors while expression, extensibility and maintainability. Most of these are part of the languages, compilers and development paradigms. Once you are convinced that this is the focus and you found a way of expressing, debugging, verification and validation, well, to a limited extent we can have support for good expression, ease of expression, ease of debugging. We can still argue that the ease of expression indicated by languages like C++, Java and other things are still Greek and Latin. Yes, it may be, but then the fact remains that we cannot do anything simpler, because eventually it has to get into the machine, and 6 decades we have taken to understand that to express the solution in a way the machine can execute is a challenge by itself. We have talked about compilers, we have talked about development paradigms. So verification and validation is a goal, but it is a stiff challenge. We are not able to talk about correctness, we are able to talk about working solutions. Prevention of errors while expression, the compiler is going to do that. So many years back, 2-3 decades back, there was an organization that is a specialist compiler designer. If you can, this was in Irvine compilers, it was called Irvine compilers. Compilers were being written A lot of compilers were being written. For any programming language you need a compiler. A lot of compilers were written, and what happened is that the compiler was tuned to what is called the grammar of a language, how the constructs of the grammar, the syntax happens. It is not talking too much about what is the executable based on the syntax, it is only talking about whether the syntax is matching. The statement belongs to a programming language statement, is it belonging to the context free grammar, which we have evolved. That is all it was checking. Gradually we started making them better compilers, optimizing compilers, intelligent compilers. Compiler writing on its simple task was not such a big exercise, because we have created lex and yak tools, lexical analysis and yet another compiler. If you can give me the context free grammar, in a few days your compiler is ready. So, what is the story about Irvine compilers? You tell that these are the 40 people who are going to develop the program. We will study the people, we will find out what are the errors, most probable errors which they commit. This compiler will automatically flag, look for them, it becomes much better. So, we found that compiler is expected to take 50% of the errors away at the time of expressing the solution. Remaining 50% the programmer. The programmers are necessary. Again, a river half crossed is not crossed at all. We need to answer what to do with the remaining 50%. As the code segments became larger, we were thankful to these people who were writing up compilers, and what we thus arrived at is 50% compile time exercise is useful. Then we talked about the language, ease of debugging. Not much time is possible for verification and validation in this method, neither is verification and validation so simple. Prevention of errors is a goal of software engineering. It takes the bigger picture, not merely the problem, the program and program engineering. It is necessary to understand that there are other phases which impact this particular exercise. We are very good sequential thinkers, but that does not mean nothing else is happening around what we are talking as sequential. What is the problem solving? If that is a keynote, defining the system. It tells, saying that there are systemic constraints, you cannot simply unilaterally go ahead and make some decisions in that sense. So, after all these things are over, we will say that we draw a line on the design phase, choose a language, press a button, the code should come. English description of what system models to meet a requirement or specification may be written by non-programmers. That is the advantage. We want the problem to be specified by the people who are actually facing the problem. Now, please understand that the best of the scientists have the difficulty in expressing both the problem and its solution. It is a matter of serious concern as to how to express the problem and how to express the solution also. Some of the solutions were so brilliant, it took quite some time for them to write up the solution. So, what we have been talking about are defining the system not necessarily by programmers, but by people who are called stakeholders. Analyzing the definition, study definition for thorough understanding, decide what details are necessary and unnecessary. We have done up to this point. So, to summarize, we talked about an analysis and design phase, and by the time we come to the conclusion of the design phase, the technical, the essential, the functional, the non-functional requirements are in place. That is the model. And what is the object oriented helping us in doing the analysis and the design in a manner where the development can start once the components have been identified. We will put them together and show some progress at the earliest. Essentially, this method is increasing the people productivity. If that is done, if that is achieved, then we have done a good deployment of this new paradigm called object oriented paradigm. That is a development paradigm. Thank you. We meet in the next lecture.